My girlfriend and I recently got into kayaking. Everything I get into seems to end up being a DIY project of sorts, so in this video we're going to build our own carbon fiber Greenland paddles.
Say, build stuff!
The plan is to 3D print the paddles in several parts with really thin wall thickness that will then get glued together with a spar that's also 3D printed, and those will get joined to a carbon fiber tube for the shaft or the loom. The hollow parts will get filled with a 2-part expanding polyurethane foam to make them watertight. The assembly will then get filament wound by hand with carbon fiber. Then epoxy will be applied and heat shrink tape will be wrapped around it for compaction. And because this process is flawless, the finish will be perfect and no sanding will be required. Just kidding, of course, there's going to be an absolute shitload of sanding. The Greenland paddle is pretty neat. It's named a Greenland paddle, named after the country where the natives used kayaking for many generations for hunting. And these were the types of paddles that they used. And you can see that the blades are kind of like a high aspect ratio wing as opposed to the sort of round spoon-shaped paddle blade you think of a more traditional style kayaking paddle, although I guess this is actually the traditional style. Anyways, it intrigued me, and so I wanted to try it. The shaft, or loom as it's called, is going to be made from a 30 millimeter diameter by 700 millimeter long carbon fiber tube, and then the paddle blades themselves will be printed in these 4 sections here. And the 2 middle sections I just modeled as solid and just used the slicer to print a single perimeter part in vase mode. The inner and outer sections here, I couldn't do that. They had a little bit more advanced features. The tip here, I wanted more wall thickness on the tip to make that maybe a little bit more durable. And then all the blade sections are joined with this spar, which runs down the length here to help align and join the sections together and maybe also add a little bit of stiffness. The plans for the geometry of this paddle come from Cape Falcon Kayak. Check them out, capefalconkayak.com. They have Greenland paddle plans, which is a PDF for $12 that contains a lot of really great detailed information on the Greenland paddle. And well, they're making them how to make them carved out of wood, but it includes the plans that I use to generate the geometry. So check out capefalconkayak.com. They have a lot of really cool stuff. They sell plans for building your own skin-on-frame kayaks. A lot of really good info on there. They also have a really great YouTube channel with tutorials on building and general paddling skills and really great stuff. So check out Cape Falcon Kayak. And if you'd like to check out the CAD for this project, the link in the description below to the On-Shape model. Take a look there, and if you want to try and print it or build one yourself, that will have what you need. The paddle blade sections are printed in ABS CF Core from Tech because I like that material and I like the way it prints. The spars are printed in Tech PPA CF, which is the stiffest and strongest material that I think you can get for consumer grade 3D printers. It would be better if these were proper carbon fiber, and also I have to glue them together, which is maybe not ideal, but they ended up working out. I then used Gorilla Glue to join all the parts together. I should point out that I'm really not looking for much, if any, strength from the 3D printed parts. It's really just, they're just there for the form, right? They're going to get filled with the expanding foam, so it'll be watertight, and then they're going to get wrapped with carbon fiber, and all the strength is going to come from that. So really just the 3D printed parts are just for the form, for the shape. Once assembled, I used masking tape to hold the sections together and in the right shape while the glue dries. Lastly, I add this little round cylinder at the end of the spar here, and you'll see why we use this later on. Okay, the two-part expanding foam is cool stuff, but it's not going to work if I just try to pour it down inside the tube. It's pretty thick and viscous, and it also starts to expand. It sets off like really quickly. It's like 45 seconds. So if you just try to pour that down a narrow tube, what's going to happen is it's going to stick to the sides about partway down, and then it's going to start to expand before the liquid gets all the way to the bottom. So you're going to have like a massive air bubble at the bottom. So you need a way to inject the foam resin down into the narrow tube where you need it. So for that, I'm using these epoxy dispensing containers and mixing tips. I 3D printed these little funnels to help with getting the foam resin into the dispensing containers. In addition to the mixing tip, I also added this tube so I could put the tube way down into the paddle and get the expanding foam resin right down at the tip where I need it. This works okay, but it's kind of hard to tell how much resin you actually have in there or how far the foam has expanded, and you also end up wasting a lot of the resin as it's all inside the tube and it starts to expand in the tube. What I found works better is just to cut a hole every 8 inches or so in the side of the paddle blade and then just inject the foam directly. This way you don't waste all the resin in that tube, and you can also see when the foam starts to expand because you'll see it start to ooze out of the hole that you cut, and then you just patch the hole with a piece of tape. This will leave some blemishes on the final product, but that's okay. The foam is really easy to cut and carve, and the whole thing kind of needs to get sanded down anyways. The loom gets a nice coating of Gorilla Glue, and then I apply the last injection of expanding foam to the top of the paddle, and then once I see it started to expand, I then insert the loom into the paddle blade. I 3D printed some guides and then set the whole thing on my floor to make sure that it was flat while it was curing. I also drilled a small hole in one end of the loom. This was to allow an air vent so that when the second blade was inserted onto the loom, there was a place for the air to escape to. Otherwise, the expanding foam would apply a ton of pressure and could do bad things to the shape of the paddle blade. Learned that lesson the hard way. After assembling 2 paddles like that, it is finally time for the carbon fibering. I drew these lines at 60-degree angles to just use as guidelines for wrapping the carbon fiber. I also made these bearing-supported rollers to help with rotating the paddle while we wrap. And here's the purpose of that little round peg we added previously. In addition to fully winding carbon fiber at 60-degree angles around the paddle, I also added some fiber at 0-degree angles to hopefully help with the bending strength. We'll use 3M Super 77 spray adhesive to tack all of the dry carbon fiber to the paddle during the wrap process. I'm just adding a couple of toes of carbon fiber to each side in the 0 direction. I have really no idea if this will do much for the stiffness, but it seemed like a good idea at the time. It's quick and easy to do, and there's not really much weight penalty, so why not? The wound fibers will be in a plus and minus 60-degree orientation, so not really optimal for the bending orientation, so that's why I thought maybe some extras. I scored this massive roll of Toray T700 24K carbon fiber from eBay for like $90. This is enough carbon to wrap at hundreds of paddles, so I'll have plenty of extra. But I definitely really wanted a really large spread toe like this 24K to minimize the number of actual hand rotations we would have to do to actually wrap the whole thing. The tips were quite tricky to wrap the fiber around, so we would end up just cutting this flush with the tip and starting a new toe for every pass. You can see the toes not lining up perfectly with the guidelines, and the guidelines are there just to help kind of eyeball, because you can sort of see parallel lines pretty well, I figure. So I figured if I can see a line, that I drew at 60 degrees and I can kind of get the toe parallel-ish, then I should be pretty close. In the locations where we cut and restarted the toes, we used more spray adhesive just on a foam brush to get it to stick down. This works surprisingly well, but it is a bit tedious. Here's the final wrapped paddle. It looks really good. It took about 2.5 hours to wrap the first one. After that, we got the procedure down, and we could do it in around an hour and a half. We'll be using Total Boat Epoxy for this, which seems like is kind of a popular epoxy for hobby-type projects like this, and you can get it on Amazon. This is the slow hardener, so we have plenty of working time. Of course, it's usually best when doing wet layups like this to apply epoxy to the surface first, and then your fabric, so you're kind of pushing the epoxy, the fabric down into already wet epoxy, but that's not really an option when doing this sort of dry layup technique like we used. So we adopted this sort of dab and spread technique with these foam brushes. We're kind of sort of jabbing the surface with the brush. My thinking that maybe you're sort of helping to push the epoxy down, into the fibers. I have no idea if this is really effective. The overall products seem to work out pretty well. And we also kind of just used a lot of epoxy, kind of an excessive amount, to make sure that we had, a good coverage. I didn't want any dry spots. Then after the epoxy is applied, we're using heat shrink compaction tape for compacting and consolidating and smoothing out our laminate. This sort of works, but what happens is it's actually not that great for the more flat-bladed section, because the heat shrink applies pressure, in an even circular cross-section profile. So when we have this flat section here, it's really not applying much compaction at all to the face of the blade, really only to the edges.
This way.
This effect is really apparent when you hit it with a heat gun and it starts to squeeze out excessive resin. You really only see resin getting squeezed out from the more cylindrical cross-section parts of the blade, up further towards the loom. And then out at the paddle blade section, it's flat and there's almost no compacting happening. Once both blades are wrapped, I use the floor technique just like before with the foam to make sure that the paddle stays flat while the epoxy is curing. And the next morning it's time to remove the compaction tape, which is pretty satisfying. And the end result is actually pretty decent. If we wanted to, we could totally just smooth out the tips and take this thing out and go paddling with it. But we want a nice finish, and so it is going to require a crap load of sanding. I'll spare you most of the sanding footage because, well, actually I didn't really shoot much because it all looks the same. You know what this process looks like. Sand it with 180, then another coat, a finishing coat of epoxy. Then you go through all the sandpapers, your 180, 240, 320, 400, 600, 800, 1,000, 1,200, and then polish. Here it is, sanded. I believe this is after 800 grit sandpaper, but not yet polished. Unfortunately, you can still see the lines from the compaction tape. I'm not really sure why that is. I thought that the extra layer of finishing resin would sort of fill that in, so I'm not quite sure what's going on there. Maybe I needed to sand the first coat of resin further. I'm not sure. At this point, I was too impatient to give it a try, and the weather was perfect, so let's go yakking. By the way, this is my Kayak, a Current Designs Kestrel 120 from 2004 that I picked up used. This is a thermoformed ABS plastic model, which I guess they only made that maybe for a few years. Most of these are either fiberglass or rotomolded plastic, but this one is in pretty nice shape. The guy I got it from kept it in pretty good shape. And it's not the nicest boat in the world, but it's pretty fun. And Amanda has this super cute little Eddyline Sky 10 that we got an absolute smashing deal for on OfferUp. And this is such a beautiful little boat. I really like these Eddyline boats. I think they just have these really nice lines here with these sharp keel. And it's just a really nice, classy looking boat. I also want to flex that it is November, the day after Thanksgiving in SoCal. And I'm a little bit overdressed. It's super warm out here. Perfect day to go out on the water. There goes everything. I've never used a Greenland paddle before, but I watched a few YouTube videos, and so I know it's going to be a little bit different and take some getting used to. It definitely feels different. Initially, it felt rather unnatural and like it didn't have hardly any power compared to the Euroblade paddle, and it just didn't seem right. I was especially having trouble directionally. It seemed like the boat wanted to turn to the right.
yeah, directionally it's more of a challenge.
But like anything new, you kind of got to stick with it and just embrace the change and start to change your technique. It's sort of like you have to unlearn what you have learned. After maybe an hour or so, we turned around, and here I'm really starting to feel pretty comfortable. I got a nice smooth cadence, and I feel like I'm actually making decent power and forward progress and getting the boat to go in the direction that I want it to go.
Maybe a little bit.
Okay, and at this point, I feel like I'm transitioning from getting used to it to really enjoying it. It really starts to feel natural. The blade is really dynamic in the water. Like, you move it a lot. You can see me doing a forward stroke that sort of turns into a draw stroke at the end to kind of turn the boat a little bit with every paddle stroke.
I have no idea if I've been keeping it in the frame. I know, but I have no idea if I've been able to keep it in the frame.
Wide angle.
The paddle is plenty stiff and it's very lightweight. It feels very comfortable, very smooth to swing it around like this. I want to emphasize too that I'm very much a kayaking noob. This is like, I don't know, maybe only my 10th or 12th time out in a kayak, so I definitely have a lot to learn. On to the second paddle now. This is after wrapping and curing and sanding, and you can see we ended up with all these low spots. Somehow the wrap, the fiber came loose or something. I'm not sure why we had this happen on the second paddle but not the first, but alas, we have all these very unfortunate low spots in the cured part. So we'll just make some thickened epoxy with micro balloons and a drop of black dye to fill in all the low spots, and then sand it smooth. And here are the finished paddles after polishing. The finish it's pretty good. You can definitely see the carbon weave pattern, but there's a significant amount of inconsistencies. I'm honestly a little bit disappointed in how these came out cosmetically. Structurally and performance in the water, they're great. I was just hoping for something that was maybe, a little bit closer to sort of commercial grade quality. I used 3M Super Duty Rubbing Compound 05954 for polishing, and this stuff seemed to work great. I have a couple of ideas as to how we could make the overall finish better. It might just take some more practice. Let me know down in the comments what you guys think about that. One of the main things is I was trying to avoid building a mold. Like, maybe a mold is required. I was kind of hoping maybe we could get away without a mold, but maybe that's, the only way. Despite the cosmetic issues, the paddles seem to work great. They're very strong, they're very stiff, they're very light, and they're a lot of fun to paddle. Well, that's going to about do it for this project. I would really like to improve on the surface quality, the surface finish of the final thing, but also I'm kind of over it. Composite projects are a ton of work and are really, really time consuming and difficult. But the final results, when you get it right, are pretty satisfying. I don't know if I'll make any more paddles like this. Maybe if I get some really good ideas, maybe from you guys in the comments, we can work on improving it. But for now, I'm just going to wrap this one up. Thanks, guys, for watching so much. Don't forget to subscribe, and hopefully I'll have some more content soon.